Centripetal force and centrifugal force. Centripetal force is that inward force. Centrifugal force is the outward force. The inward force to keep an object moving. You want to keep something moving without moving away from the axis. Something like this. The force to keep maybe this car attached to this fixed point is what we call what? Centripetal force. But the force to keep it moving outward, like the force to keep it outward, which we don't really measure because the outward is like a space, it's wider. That we call what? Centrifugal force. And for centripetal force, we say is what? We say is F equals to what? Mv square over R. Centripetal force. So I can say centripetal acceleration is equals to what? V square over what? Over R. So now, best thing is to take it step by step. Let me finish this. Hey. Thank you. So now, so we speak the parameters one by one. So now we say an object of mass 2 kg moves in a circular path of radius what? 0.5 meter with a speed of what? 1 meter per second. What is angular velocity? Now, from here I can say the acceleration or I will find the, I said acceleration is equal to what? V square over what? Over R. So I can say, okay, A is equal to what? V square over R. So V, that's what? 1 square over what? 0.5. So I say that is what? 2. So my acceleration equals to what? 2 ms minus 2. So now I can get that, okay, you should know that, here, for centripetal acceleration, for V is equal to what? Omega R. And we said the V is linear speed and the omega is what? Angular speed. We can say for acceleration is equal to what? Minus omega square R. It's a formula you have to know. Acceleration equals to minus. But you can neglect the minus. It's just there for some certain proving. Minus omega square R. So now I can say my A is what? 2 from that place. You can neglect your negative sign. Omega square and what? And R. So my R, that is what? Times, from the question, 0.5. So I will say omega square equals to what? I will explain again, don't worry. I'll explain again. 2 over what? 0.5. Okay, let me explain again. I said an unit of mass 2 kg. Mass is 2 kg. Moves in a circular path of radius 0.5 meter. Radius is what? 0.5 meter. With a speed of 1 meters per second. So that is speed. V is equal to what? 1 ms minus 1. Now, you have to find angular velocity. But now you can actually get the what? Centripetal acceleration. Using centripetal acceleration, you know that, okay, A is equal to what? V square over R. From what? That F is equal to mv square over R. So I can say, okay, A is equal to what? 1 square over what? 0.5. So 1 over 0.5, that will give you what? 2. So my A is 2. And then you know that, okay, A is equal to what? Minus omega square R. You can get the minus sign. So 2 equals to what? Omega square times what? 0.5. Because the radius is what? 0.5. So I can say, okay, omega square equals to what? 2 over 0.5. That will give you what? 4. So from this place, my omega square equals to what? 4. So I can say my omega is equals to what? 2. You don't say the unit for linear velocity, for velocity is what? Ms minus 1. But the unit for angular speed, since you are using something like an angular, so not like a normal speed, you can use what? Rad. That rad means radians. Radians is a way of measuring degrees. Measure degrees, you use what? Radians. So that is radians. So that is 2 rad per what? Per second. So please don't forget centripetal acceleration, centripetal force, linear speed, and acceleration too. And all these are still somehow linked to simple harmonic motion. And you know that okay, SHM2 is an important topic for you to know. So that is all. My answer is 2 rad per second. 2 rad per second. So next question. So this one is a kind of application question and it's very basic and it's just like common sense. A stone is tied to the one end of a light string and wheeled in a vertical circle. Wheeled means like you are rolling it. The tension in the string is at maximum when the A stone is at top of the circular part. It can be that one. B stone is at the bottom of the circular part. Yes. At the bottom. Yes. C string lies in an horizontal direction. No. D stone is at another point along the path. No. Why it's maybe why it's B? If you think about it like David and Goliath story, or maybe when you want to actually make sure that you hit a parting point, particularly you if you release the like stuff, the rope attached to maybe the stone when it is like reaching that bottom on circular path. You know when you are like rolling it, it's at this point, the bottom of the circular part where you have the highest tension. So it's from here you release it. You get, and don't forget that the formula for tension, it has many formulas. It can be a force. It's more than Newton. It's vector. But at times we say the formula for tension is equal to what? M open bracket what? A plus G. A plus G. It can be plus, it can be minus G. But you don't know that tension equals to M A plus G. Or we can say okay, it can be minus 2 in some cases. So we can say okay, tension equals to MA. Let me put G first. Let me put A first. It can be MA plus MG, or T is equal to what? MA minus MG. Is this formula is useful when you get to elevator scenarios. Question that involves elevator moving up, elevator moving downwards. So the answer will be what? B. Stones at the bottom of the circular part. So next question. Yes, this one is involving SHM. So we said that a body moves. So we put a body moves in SHM. A body moves in SHM between 2 points 10 meters on a straight line, joining the points. If the angular speed. Now, I've explained the formula for this one already. I said for this one that V is equal to what? Omega R. But at times you can now have two distances. Yes, two distances, and you have to make sure that it is one. And there's a particular formula that connects or that satisfies that problem. Now, I said V equals to omega R. The what we call amplitude. Amplitude is the, it's in wave, the point of maximum displacement of a body. That is what the amplitude. It can be the crest, trough, compression, all those ones. Now, from here, we can say the V equals to omega. You know, I said when we have two distances, we can say okay, for Pythagoras theorem we have two distances. You can say okay, this one will what? Root a square minus x square. We use x as a particular point in that extension. We use a amplitude as a particular point in that extension. I know amplitude is what? Maximum. That way it's what? A square minus x square. It can't be x square minus a square because a is always more than the what? X square. Now, from this question we say okay, between 2 points 10 meter on the straight line joining the point. So therefore my a is what? 10 meter. If the angular speed of the body is 5 rad per second, that is the omega. So my omega equals to what? 5 rad per second. Calculate its speed when it is 6 meter from the center of the motion. So I'm saying this my x is what? Is 6 meter. It is now this root a square minus x square that gives me r. So I can say my r equals to what? Root of what? Of a square minus what? X square. Looking at this place. So that's what you should know. So now I can just simply impute values. So I can say my okay, my v, my speed equals to what? Omega, which is now 5. So 5 times root what? A square. A square is what? 10 square. So that is 10 square minus my x is what? 6 square. So that is 6 square. So b equals to what? 5 times. So 10 square minus 6 square. That is 100 minus 36. That is 64. So I'm saying what? Root what? 64. What is root 64? That is what? 8. So my b equals to what? 5 times 8 meter per second. So that is what? 40 meters per second. So that is what? C. So you should know that SHM is a topic that we always come out. And it can be confusing at times. You should learn SHM for your exam. You should learn SHM for your exam. You should learn it. And examples of SHM. Popular one is the motion of a simple pendulum. You should know that one. And you should also know that when you have it like this, that's 3 scenario. It can be here, it can be here, it can be here. This is the maximum having maximum. So at here, we say that velocity is what? 0. At this maximum end, velocity is 0. At this maximum end, velocity is also what? 0. But at here, acceleration is 0. So I use VAV. Velocity is 0 at the other end, 0 at this end, but the middle. So they can ask you, what is the acceleration at the in the motion of the simple pendulum at the middle? Acceleration is what? You can see maximum, you can see 1, and 0. You should know that it's what? 0. VAV, VAV. And then, okay, that is wrong. So next question. Okay. 30. Hmm? Okay, 30. Okay, 30. Okay. So now this one deals with relative velocity and relative speed. This is a very, very confusing question that you should know about, because for this one now, it deals with speed, not velocity. When speed is moving in same direction, speed is scalar quantity moving in same direction, speed scalar quantity. We say that it will be a negative sign. Speed, same direction, negative sign. But it is now when it is now involving a velocity in same direction. That one we say is a what? A positive sign. So definitely if it is speed, this velocity will also work for force, because force is also a vector quantity. For force, for velocity, since they are vector quantities, we say in the same direction, it is plus. So for that speed now, since this is a scalar quantity, speed itself, speed, majorly speed, and it's the same direction, it will be what? negative. You minus your two speeds together. But when it's now in opposite direction for speed, it will now be what? Positive. So that one I can say that okay, uniform speed of 40 ms minus 1 observes a truck approaching the opposite direction with the speed of 20 meters per second. So that is, so most people just think that maybe it's 40 minus 20. No, it is 40 plus 20. If you have checked your jam question, you see it's a very, if you check, it's a very common question. So speed, scalar, is what? 40 plus 20. That is 60. If it were to be velocity, talking about, it would have been what? 40 minus 20. Since opposite direction, it should be minus. If there's also a vector, you can use vector format like vector 6 units, 2 units. Since it's vector, that way opposite direction is what? Negative. We're talking about speed. Scalar is what? Positive. So that is option D, not option C. Option D. So next question. Yes, this one, you should know it as a constant. The gravity on Earth is what? 9.8, not just 10 actually. We say 10 just to make things simpler. To simplify it, we say it's 10. But actually, it is what? 9.8. For gravity on what? Earth. For gravity on Moon is what? 1.67 is a constant. You should know. 1.67. Gravity on the Moon is what? 1.67. Gravity on the Earth is what? 9.8. Because of the gravity of Moon that is very, very low. That is why it's easy for you to like, when you get to the moon, you can just simply like lift off. But the gravity of the moon is very, very small, 1.67. But compared to other planets that have maybe a high gravity, maybe like 19.8 or 20, the meaning is that instead of you wanting to now go up, you want to like squeeze together. So you want to like put that pressure on you to like come down. You get? So that is gravity on the moon is 1.67. Gravity on Earth is what? 9.8. You should know. So next question. Next question. The type of motion produced by a couple is something as torque. Torque. Tor tor yes, QUE. Something as torque. You know, I said movement is what? Force times what? Perpendicular distance. So when you're having torque, that maybe a tap. Yes, that is a popular example. When you're opening a tap to fetch water, that motion is what we call is this kind of motion, which is a couple motion, which is a rotational motion. You can see that it is moving around a particular axis. So you don't make this question more confusing. They can put circular motion there. But you know that circular motion is when it's around a fixed point, moving like this. But rotational, just like your answer is what? Rotational motion. So it can be random, it can be translational, it can be oscillatory. Oscillatory is something as saying vibratory motion. That is basic. So next question. Now we have three types of equilibrium. Collision. We have what? Stable equilibrium. So that means acceleration is what? So that means acceleration is what? Force over what? Over mass.